Hello, my name is Jim Mullaney from SciTech Process Solutions. Today I'm doing a vibration test in one of our test rooms for our distributor in Singapore. It is PS Solutions. They have a customer that had a rotor to be rebalanced. There was no spec on the rebalance, but on the past rotors they purchased new, they had a 500 micron balance specification. Down here you'll see, and I'll zoom in, that's the vibrometer, and actually you'll see me when I run the tool. Down below is the controller. It's rotor up failure because this is a test controller. And what we're going to do is we're going to run, they had 500, 1,000, 1,500, then 500. It turns out with a brush motor here, they won't even get to 1,000 on the 10-second purge. But we'll show you that even though this is a used rotor, we were able to balance it within the 500 micron specification, even though they didn't spec that on the purchase order. So I'll simply hit start. What I'm going to do now, the key thing is it'll be kind of boring, but I'm going to watch the vibrometer screen. Oops, wrong way. Okay, it's 0.0. So to get millimeters to microns, you move it 3 decimal points to the right. So right now, that would be 111 micron, 131, 160. 125. As you can see, it's less than 200. The specification is 500. So 0.500 would be 500. Right now we're at 400. We're at 500 RPM exactly, and we're at 1.8, 2.0. Now we're going through the harmonic on the way up. That just went a little bit over 0.22, which is way below the spec. Once you get above about 900 RPM, you'll see it starts to really smooth out. So right now we are at 1,000 RPM, 0.002. So now so basically we're running at 500, excuse me, 20, and their spec is 500. We're going to go up to, we're at 1,300. I'll show you in a second down here. Okay, let's look at the vibrometer again. 0.015, excellent. Let's go back. 1,400, we're almost at 15. When we get to 15, I'll go up and show you where we're at. Actually, that's close enough so you can see it. And look, we're at 0.0108 or 0.013 now, way below the 500 micron. What you will have is, I don't know if the customer's running a brushless or a brush motor. This is a brush motor which ramps up much slower. The brushless motor will even have a tighter specification than this. The largest harmonic you'll see is on the way down when a large rotor like this tries to break. The customer in Malaysia has both S and F models, so I don't know, again, if this is going to be to a brush or a brushless motor. It is a 4-bolt backplate, and the customer does run 4-bolt backplates on their S models, on some of them. Okay, now we're ramping back down. Let me just show you. We are at 1,000. Get lower, lower. Let's look at the... Alrighty, see, we're still excellent. When I see it, the worst vibration, I'll let you know, and I'll go down. 0.0, it looks like we're at 750 down below. 1.6, 0.16, I mean, 0.18. And let's see, that might be 500. It's almost the worst, but that's for their spec, but it's very low. 0.18 again, that's less than 200. 202, 198, so we're right around 200 is where we stabilize, and we're at 500 now. Let's look. There we go. Now we just stopped the process, and there we go. As you see, that the highest it went to is approximately 200 micron. The specification is 500 micron. So in our mind, this rotor easily meets the specification. We'll go ahead and send this video to our distributor, make sure that they're happy with it. The customer is very they have a tight criteria on the rotors being shipped, and they usually want to review everything. We have to still electropolish this rotor, but that will not change any of the vibration spec. That's only because after our rotor balance, we had to weld some different weights on. Again, this is Jim Mullaney from SciTech Process Solutions. Today is Friday, May 18th, 2018, and we'll send this video over to PS Solutions. Thank you.